Today we are going to talk about agentic AI and how MLflow can help. And because me and Mariia, we are working on Managed MLflow at Nebius, so we of course will use Managed MLflow at Nebius. Today we'll talk about MLflow a little bit, so give you a short some sort of overview, and then we'll jump into the demo. So let us introduce ourselves first. So me and Mariia, we are working at Nebius. Nebius is a AI cloud, and we provide infrastructure, compute, and services for AI developers around the globe. We have data centers in Europe, in United States. We have, let's say, two big projects right now. It's AI cloud that provide this compute infrastructure, and AI studio that provide easy to use interface for prototyping AI and APIs for open source models. So my name is Mikhail. I'm a product manager, and I exploring the field of AI tooling, trying to understand what kind of tools can help you guys in AI development. Previously, I worked as data scientist and MLOps engineer. So more or less, now I continue with this tooling for AI development.
My name is Mariia Diuldina. I am software developer, and I am the one who creates Managed MLflow at Nebius. So today I'm here to answer your questions about Managed MLflow. So if you have any, I will answer them.
And so if you're not familiar with MLflow yet, let me briefly describe what it is. So MLflow is an open source tool that provides functionality for experiment tracking, model registry, AI evaluation and observability, both for classical ML, deep learning, and Gen AI applications. And these three components we'll talk about today. Briefly, so this is how experiment tracking can look like in MLflow. So there are some simple methods and functions that you can use to track metadata about your experiments. You can organize experiments and in nice format that is easy to use and collaborate with in the team. And you can visualize results of your experiments in the pretty good UI. The newest functionality of MLflow is related to LLM observability and evaluation. MLflow provides many integrations with the Gen AI frameworks that and methods like Autolog that automatically trace LLM's calls, and a lot of details about how agents or LLMs work, and also visualize all these tons of information. And this is very handy, and we'll use it a lot of today. And of course, model and prompt management. So where you can register your models and prompts, version them. For prompts is the newest functionality, and you can compare different prompts. And by using prompt registry at MLflow, you can, for example, track and control which version of the prompt you use in your AI system and what results it produces. So it's a very handy tool. So and now it's Managed MLflow. So because this is a good tool, we are working on this and providing Managed MLflow. Mariia, can you tell us a little bit about Managed MLflow at Nebius?
Yeah, the question is, why do you might need a Managed MLflow? For example, if you're an AI engineer and you work yourself and you're just prototyping and you want to deploy MLflow locally on your laptop, it's pretty easy task. You just type MLflow server and that's it. But if you, for example, work in a small team and you need some deployment which is accessible by every member of the team, it already might be a tricky task because deploying the reliable and secure solution, it might require you pretty strong knowledge in DevOps or MLOps. We have MLOps here, you know how painful can be. So it's not only about deploying it once, but once you have the deployment, you need to maintain it. You need to keep it, upgrade. You need to make backups. You need to set up observability. You need to deal with fails and so on. So we in Nebius, we just do everything for you. And you literally can create MLflow by one click. You just click the Create MLflow button, you type the name and the password, and that's it. We do everything else just for you. So, yeah, that's basically it. And if you have any question about Managed MLflow, just type them in the Q&A section, and I will answer them.
Thank you very much, Mariia. Thank you very much. Yeah, great introduction. Let's continue. And we will start with the demo that we prepared for you with MLflow and CrewAI. So we built a simple AI agent. Not very simple, actually, unfortunately, because we spent a lot of time to debug it and to figure out how to use it, like how to not overcomplicate things and still show most important functionality that's provided by MLflow. But I guess it works now. So you'll see, and the idea that we want to show that how the complexity underneath of agentic AI work, and that there are a lot of steps with non-deterministic behavior, and that is very difficult to track and debug, and actually how MLflow, of course, help with this. This is the point of our talk today. And as example, we prepared the agent that use this flow. So we'll build a simple AI agent with CrewAI. So CrewAI is a framework for agentic AI development. So we'll see how it works. Then we'll try to figure out what is going on inside the agent. And then we'll write some problematic questions that I guess like you experience as well during this development, and see how MLflow help with this. So, and during this demo, we want to ask a couple of questions to you just to stay aligned with like real problematic that you have on your side. So please feel free to add your insights and post your questions to Q&A session, of course. Okay, let me start with the demo. And for demo, we need the Managed MLflow. So if you are not experienced with Nebius cloud, so inside the Nebius, you can find a lot of like resources and services, and managed service for MLflow is one of them. So we just go inside and open the web UI that we'll use. And also I launched the Jupyter Lab application also at Nebius, so you can find it in the applications menu. And this Jupyter Lab will guide us through step by step. And all these materials I kept in GitHub, so you'll find the link in slides, and you can find all this code. So we will not deep dive into the code itself, but we'll go step by step during the workflow we just discussed. So before we start, before the first step, I want to so you'll need, of course, like prepare the environment with a couple of environment variables for MLflow and for Nebius Studio. Okay, let me just do a step back. So, for example, if you want to try follow this demo by yourself and Nebius Managed MLflow, so you can just go to the running MLflow cluster, find this how to connect button, and you'll see all the details that you need to specify, like password, URI, etc. So you just specify them in the .env file here, and everything should work. And for Nebius Studio, so here I actually use OpenAI and Nebius API key. So for OpenAI is like ManLM I use here, and for Nebius Studio is also like our project that hosted many open source LLMs for different purposes, and you can use it for your needs. And we'll use Llama 70B for evaluation purposes here. That's why I use it. But If you like, you can just substitute this with OpenAI API key or some other provider, and this should work. Okay, I think that's it with the preparation, and let's jump into the quick step one. And let's start with quick implementation of AI agent. So let's say we take AI and we implement some agent and run it, right? So what usually problems do we have? Usually you want to understand how to track what happens during the agent execution and to figure out how to improve it, how to debug it, and make it fast and cheap, right? This is how I what I experienced when I first started with the agentic AI. And if you have the same and it makes sense for you to just let me know. And if you're not know what is Crew AI, I'll just give you a brief introduction. So Crew AI is a framework for agentic AI development, I told you. And when you go step by step, so usually you need to define some tools that we'll use. So in this case, it's a web search tool, and you define agents. So for agents, we need to provide what is the role, what is the goal, and some backstory as a context for this agent. And here, the idea of this demo that we are building, actually, it's not one agent, it's a crew. The name of the crew UI, right? So it's a team of agents that collaborate on some tasks together, right? And completing one task, agent will just pass the results to another agent and he will proceed. The idea of the agent that we'll build today is to find AI tools that are relevant to our project. Let's say we are working on RAG for our company, and we have a couple of tools that we're using right now. Let's say it's a Postgres and maybe LangGraph. And we are looking around and trying to understand what other tools can we use and should we use in our project. And this is what this group can help with. So research agent will find the information about relevant tools on the market, right? And analyst will analyze this data and prepare the nice report for us in Markdown format that we can share and analyze and use somehow. So we define those agents. Then we need to define tasks for each agent. Here we just combine all tasks under the one class, IOPS research tasks. But first task, we need to search over internet for the tools that we need. That's specifically for our task and based on the stack of AI tools that we have right now. Then we'll need to analyze them, right? So their capabilities, limitations, compatibility with our AI stack, and then summarize all these findings to let people easily understand and make decisions. So, and with agents and tasks, we can combine everything in Crew. So, and this is how it looks like. In the Crew, using this Crew class, we just specify what agents we have. We specify tasks. In this simplified version, it's just sequential process. So it means that every task will be executed sequentially, and we can just run it. So we define the task for this Crew. So we want to develop this conversational RAG system to work with PDF documents collection, and this is our existing stack. So the agent starts working, and we can see a lot of logs here. So something goes well, but there are also some possible problems with internet search. Usually they're at the beginning because this is the first task, right? And so it's a lot of information. The logs are very detailed and well organized. So, and this is the great job by QAI, but it's a lot, and you need to understand somehow. You can manually to go deeper into some details of every task, and for example, to see the final results as here, or you can see results of every task inside. But this anyway is a manual, and it's not handy, right? So, and I see that many people answer that this is experience this problem that you need to understand what is going on inside the agent. So let's stop here and go to the second step. So let's say this is our prototype. It works. That's great. So now let's think about how we can improve it with MLflow. And we can do it actually in one command. And here is just QEI autolog. So second question for you guys. What aspects of agent execution would you most want to track? So what is important for you in most of the time? So again, we have agents. We have the tasks that they execute. We have different tools that agents can use. It could be calling LLMs. The tools can be just some other custom scripts, whatever. It's like rabbit hole with a lot of combinations. So what is the problem and how the MLflow can help? I see that you select that reading steps and decision process is important, as well as the tools and token usage. Yeah, token usage and cost optimization is, of course, important for every business. Okay, guys, so let's look at MLflow. So with only this command, QEI autolog, we enable MLflow to track all information, or maybe almost all information that you need in a single command for your agent. And here we just organize all this finding on the separate experiment. We call it step 2 autolog. And let's navigate to this experiment and we'll see the traces. So when you run this agent system, this crew, actually MLflow will trace the results of this agent work into these traces, and you see it like this here. We can open it. Can you see that here, exactly what we need? We have different tasks that actually it's a three task that we defined. For each task, we see that who executing this. This is one agent. You can name those agents, of course, but we didn't do this, but you can give them pretty names like Mikhail or, I don't know, Hercules, whatever. So inside this task, we can see what's going on inside. So there are some work with the memory, long and short of memory. We can see LLM calls, of course, and you can see there are a lot of LLM calls. And for each call, for example, you can see prompts, the system and user prompts, and also find the attributes that used for this LLM call, like a model. Here you could find specific parameters for LLMs. I didn't set up them, but you can find them. And also in many other systems, right, that generate a lot of logs, you can find the results of execution. Actually, you can also track the whole log of execution here. If something goes wrong, so you'll see the trace of the with the log here. I don't have, I guess, this example here, but it worked for me like that. Okay, so you can see that there are a lot of information about this execution, as well as statuses, as well as execution time. And oh yes, we also can track the timeline for every step. And this is pretty useful information when you want to debug the speed of your agent. So you can find the longest tasks and try to optimize them somehow. Or you can find it, I guess we have it here. Not exactly. Okay, we'll find it later. That for every LM calls, not for every LM calls, but QEI also provide you information about tokens that used to for these LLM calls. Okay, so it was simple, right? So we just use one command to autolog all these details. Let's go to the next step. And what else we can do here? So we have a question now. So we have these traces in MLflow, and But how can we measure and compare the agent performance across multiple runs, right? So we can see there here a lot of these traces. So each trace here is a different run. And we can go inside and we can find the final, the report that generated by the crew is here, and it looks pretty nice, but it's pretty difficult to compare them between each run and select the best combination of your prompts, parameters, and LLM models they use. So the question is how MLflow can help, and of course it can help. And here we'll use standard classic, I would say, MLflow functions for logging parameters, metrics, and artifacts that can solve us these problems. I will not deep dive into the code, as I said, but what we used in the code for this section, actually these four methods. And for the crew we developed, there is a method, the usage metrics, that provides information about number of tokens used in these LLM calls. Okay, and thank you for answering the question. So, and I see that output quality scores and token usage is are very important and very popular problem. That's good that we are aligned and understand. We have actually common ground here, right? Okay, so if you run this step with the methods for logging and tracking, we go to the next experiment here, step 3, and we can see that here a lot of experiments. So here our traces, and here are runs of our experiments. So let's just quickly set up columns that we want to see here, and here we can see tokens and parameters and tags, something like that. And you see for every run, we can now track how many tokens used and generated. And we can go further and just multiply number of tokens by the costs of LLM that you use to produce them. And you can track the real money here, if you like. And also, just for visualization, here you also can track parameters. In our cases, stack and that we use, and tasks that we want to solve. But this is just for visualization, let's say. But what you also can do here, you can compare all these runs and find, for example, the run with the minimum tokens used, so it's the cheapest one, and find the artifact if it's successful, or if it's not successful. Actually, let's just group them by status. So, and we'll navigate only into a success group and find the runs only for successful. So a lot of functionality here that you can play with. And let's go to the next step. So we have our metrics. We can use metrics functionality at MLflow. What we can do next, of course, we can evaluate the output quality of our agent. In our case, it's the final report, right? So we want to see that the report is meaningful, is relevant to our task, and we can come up with a some evaluation function and evaluation metrics specifically for our task. And again, so MLflow can help with this task as well. You can track quality inside MLflow. MLflow have set of traditional metrics, not traditional, but standard metrics for LLM calls, for LLM evaluation. And you also can design your evaluation function that takes the final report and return some metrics. So here we tracked some of them. Let me show them. It's they are here. So it's accuracy, completeness, relevance, and overall quality. Let's see them. Okay, so here they are. So by using some metrics and tracking them with MLflow, we can easily find the most successful runs based on specific metrics and understand how we run it and what kind of prompts used and other parameters, and see with artifact actually tracking. I didn't show it before, so that all you can track all outputs of each task here with MLflow and easily navigate to them, as well as, for example, logs of execution of this system. Okay, and now we are going to the last step. Actually, step 5 is about prompts. So prompts are kind of hyperparameters for GenAI, right? As we had it in MLOps. And by tweaking the prompts and changing prompts, you can improve the system and actually manage behavior of your agent. So, and the question is, how do you track which prompt was used for which run and compare outputs? So, do you have any problems with prompts? So, the new functionality at MLflow allows us to create and register prompt template inside MLflow and version them. For example, we have the simple prompt here. Then we update this prompt, and this is prompt for the report generation. And the new one, you see, like adds more structured and clear requirements what we expected in the final report. And then okay, let's look how it looks like in MLflow. So here's our prompt, latest one, the latest version, and we can compare this latest version with the previous one, for example, and see this is the simple version, and this one is the latest one. So you can see the difference between the prompts, and you can utilize this functionality to select specific version of the prompt here in the script that right now, so by default, it just returns the latest prompt. Okay, so we can download this prompt, use this prompt inside our task to instruct agent what we expect and what it should do. And yeah, and when you run it, and again, track everything with MLflow, you'll see everything, all metrics, all prompt. You can specify version of prompts that you used, set it as parameters. You can see traces, and it seems like we covered most of the problems and challenges that you might experience with the agentic AI. So I guess it's not everything, and you have a lot of more practical problems, but we try to focus on the most common problems. Okay, I guess that's it with the demo. So just to conclude, if you never used MLflow, it makes sense to try it. It provides a lot of functionality for GenAI applications and agents development. If you want to have MLflow solution that is robust and suitable for your team, and you need GPU workload, you can definitely check managed MLflow at Nebius, right? And try it. Please go to Nebius, try MLflow, and give us your feedback. I'll be happy to chat with you on LinkedIn or via email. So hear your feedback. I guess that's it from my side. I just want to thank you for joining us today.
Yeah, thank you so much, everyone.
Thank you, Mariia, for assisting me, and thank you, Mariia, actually, for building this Managed MLflow at Nebius. This is because of her, so we have this tool. Again, let's keep in touch and see you next time.